Example 2, list all possible rational zeros. So let's look at the equation that we're going to eventually find the actual zeros to. So we're looking at f of x is equal to x cubed plus 7x squared minus 8x minus 14. So using the rational zero theorem to find, let's get part A, the possible rational zeros, we're listing all the possible factors of the constant term, all over the factors of the leading coefficient. So we're going to list all the factors of the constant term. Our constant term here is negative 14. So listing all of those possible factors, we have plus or minus 1, plus or minus 2, plus or minus 7, plus or minus 14. And then we're going to list all the possible factors of the leading coefficient, which is 1, plus or minus 1. So let's divide this out, and our possible rational zeros are plus or minus 1, plus or minus 2, plus or minus 7, plus or minus 14. So then we're going to use synthetic division, this is part B, to test the possible rational zeros and find an actual zero. Our goal at the end of this, as of course we're going to solve, but we're looking for all the possible, or all of the actual zeros that are on the x-axis. Remember, we talked about this in the previous section. So if we're looking for the actual zeros, okay, we're looking for points that will be on the x-axis, positively and or negatively. Now, how can you determine the number of actual zeros that you would have if you were to graph this equation? Well, look at the leading degree, or not leading degree, our highest degree. Our highest degree tells us the number of actual zeros that will be in that graph. We have 3. Now, part A says list all the possible rational zeros. We have 2, 4, 6, and 8 possible rational zeros, but really, in actuality, we have 3 of them. So we need to find those 3, and we're going to find those 3 first of all, starting off with using synthetic division. And we're going to look at each factor, plus and minus, and one of these, when we use synthetic division to simplify the polynomial, will give us the remainder of 0. And remember, going back to in your textbook, we talked about, or excuse me, go to your notes, we talked about, I want to say what page it is, page 80, we talked about the factor theorem that says that whenever you have, it says the factor x minus c and the root c are the same thing. So once we find, we have that 0 remainder, it's going to give us, we're going to have one of those factors, the x minus c, meaning our divisor. So let's begin with 1. Using synthetic division, let's list our coefficients. We have 1, 7, negative 8, negative 14. And let's start, bring down the 1. Then we have 1 times 1, that is 1, right under the 7. And add 1 and 7, we have 8. Then 8 times 1, we have 8. Add 8 and negative 8, we have 0. And then 0 times 1, we have 0, and add 0 to negative 14, we have negative 14. Okay, so we have a remainder of negative 14, and we're looking for a remainder of 0. So right now, our possible rational 0 at 1 is not possible. It won't be our actual 0. So let's try negative 1. We will just go down the line and see which one of these, the first one that gives us the remainder of 0, will be the first factor that we would use here. So we have negative 1 as our divisor, and we have here 1, 7, negative 8, negative 14 again. And let's use synthetic division. Bring down the 1. 1 times negative 1, we have negative 1. Negative 1 plus 7 gives us 6. 6 times negative 1, that is negative 6. Negative 6 added to negative 8, we have negative 14. Negative 14 times negative 1, we have 14. And add 14 to negative 14, we have 0, our remainder of 0. Therefore, going back to that factor theorem, we have negative 1 as our solution is the same thing as saying, let me say this, negative 1 is our solution because we have a 0 remainder, but it's the same thing as saying x plus 1 being our divisor. Remember in synthetic division where we have to take the opposite of the constant here, and this is where we get the negative 1. Okay, so we have one solution, which is negative 1. Now we need to find the others. We know that we're going to have 3 actual zeros. So for part C here, it says use the quotient from part B, our quotient, our answer, which is the 1, 6, and negative 14, which becomes x squared, 1x squared, 6x, and negative 14. So use the quotient from part B to find the remaining zeros of the polynomial function. So we have one factor, x plus 1. We know that's going to equal to negative 1. And then we have here x squared plus 6x minus 14 equals to 0. And then we're going to factor. Or first of all, let's set each factor equal to 0. And we have here, of course, we already know that our one solution is negative 1. And then our other ones, we have x squared plus 6x minus 14. We think of factors of 14, 1 and 14, 2 and 7, and we're looking for possible factors that would give us 6, the middle term. It doesn't help out, or it doesn't work. Now let me say this. Anytime you come across a quadratic equation where it is not factorable, then you have other choices, completing the square or the quadratic formula. Well, here we'll use the quadratic formula. So our A is 1, our B is 6, our C is negative 14. And here we go. X is equal to negative times 6 plus or minus the square root of 6 squared minus 4 times 1 times negative 14 all over 2 times 1. Then we have negative 6 plus or minus the square root of 36, and we're going to multiply negative 4, 1, and negative 14. We have positive 56 all over 2. That is equal to negative 6 plus or minus the square root of 92 all over 2. So now you have two solutions. Okay. And your two solutions are, we can say negative 6 plus the square root of 92 over 2, or negative 6 minus the square root of 92 over 2. Now we can simplify the square root of 92. We can find factors of 92. and one of its factors would be a perfect square. We have here 4 times 23. Take the square root of 4. And we have negative 6 plus 2, square root of 23 over 2. And we can do the same thing for the minus. Negative 6 minus 2, square root of 23 over 2. And then if we want to here, we can divide 2 into each term. And we have here negative 3. So one solution here, negative 3 plus the square root of 23, or negative 3 minus the square root of 23. So our three actual zeros are negative 1, negative 3 plus the square root of 23, negative 3 minus the square root of 23.